All right, balancing redox reactions. These are reactions where water, H plus OH minus, may take part in the reactions. I'm going to use what used to be called the ion electron method. Sometimes it's called the half reaction method, where we look at our overall reaction, split it up into the half reactions, balance the half reactions with respect to atoms, then with respect to charge, and then add everything up and see what we get. All right, very simple. So the first thing is you need to write the ionic form of your reaction. Here's our reaction. Hydrogen peroxide plus Fe2 plus is going to go to Fe3 plus H2O, and we will be given information. This is in acidic solution. This is information you'll need to know whether it's acidic or basic solution because you balance them slightly differently. So it's in its ionic form. There's no counter ions at this point. What is with this iron here? Is it chlorine? Who knows what it is? We're not going to worry about that because it won't change its oxidation state. So then we have to separate into half reactions. Well, the first half reaction is pretty easy because we see that the iron 2 plus goes to iron 3 plus. So iron 2 plus goes to iron 3 plus, which means the H2O2 must go to H2O. Note, 2 plus goes to 3 plus. It's gaining positive charge. Our iron is getting oxidized. Something in here must be getting reduced. The truth of the matter is, when you do your reaction this way, we don't worry about it. We don't worry about what's getting reduced. However, just for our own peace of mind, can you see that hydrogen starts as +1, ends as +1? Oxygen starts as -1 and ends as -2. Therefore, the oxygen is getting reduced. That's a nice thing about this ion electron method. We don't have to worry about it just yet. We just need to separate the two half reactions. Next, we balance everything other than oxygen and hydrogen. Well, the first reaction just has oxygen and hydrogen, so we don't worry about it. Second one has one iron, one iron. Okay, everything other than oxygen and hydrogen is balanced. Yay. Now things get a little weird. Now we need to balance oxygen, and we're going to balance oxygen by adding water. So yeah, we're going to balance oxygen by adding water. And so the first step, in this example, I've gone through a couple of steps already. The first thing we're going to do to balance this using water is say, all right, I had up here H2O2 goes to H2O. I've got two oxygens here, one oxygen over here. The only thing I can add is water, so I need to add another water to this side over here to get two oxygens. So I just put a 2 in front of my H2O. Now I have two waters here, two oxygens. So I added water to balance out my oxygens. I now have two oxygens here, but note I now have 4 hydrogens, and over here I only have 2 hydrogens. Since we said it's in acidic solution, we can balance out the hydrogens with H+. So the step 4 of this is you're going to add H2O to balance oxygen and H+ to balance hydrogens. So I added 1 extra water to give me 2 oxygens, O2 here, O here, got 2 here. I've got 4 H's, I had 2 H's here, so I need to add 2 H pluses to balance this out. All right. Once you've got everything balanced, so now up here we balanced everything other than hydrogen and oxygen. Down here we added water to balance the oxygen, and then added H+ to balance all the hydrogens. All of our atoms are balanced. Our charges are not yet balanced. So in the next step, we need to add electrons to balance all the charges. So if we look at this reaction here, we've got 2H plus H2O. Well, let's look up here before we get nasty. 2H plus H2O2 goes to 2H2O. No charge on this side, but we have a +2 charge on this side. The only thing we can add is electrons. Which side do we add electrons to? Well, if we added electrons to the product side, that would make this 2 minus, this would make this negative and this positive, and then that's not equal. The only thing we can do is we've got 2 extra positives here. We need to add 2 electrons to this side because 2 positives plus 2 negative electrons make this side neutral, and this side is also neutral. So that's what we do here. We add 2 electrons to the reactant side because 2 negatives counteract the 2 positive to make the reactant side neutral, and the product side is neutral. When we look at the iron reaction up here, this is 2 plus and this is 3 plus. Can we see that if this is 3 plus and the only thing we can add is electrons, we have to add 1 electron to the 3 plus side, because 3 plus our 1 electron equals 2 plus. So we did it here. 3 plus 1 electron, 1 negative is 2 positive. Note, as a check, since this is redox reaction, something needs to get reduced, something needs to get oxidized, which means your electrons need to be on opposite sides of the arrows for your 2 half reactions here. For this reaction, the electrons are on the left side of the arrow. Here, the electron's on the right side of the arrow, so that's good. First check. If you find you've added electrons to the right side up here and the right side down here, you have done something wrong. All right. But, note we've added our electrons, but we need to equalize the number of electrons in both reactions, because these 2 electrons that get added to the reactant side here, where'd they come from? Well, they must come from down here. The iron is going to give up electrons and give it to the oxygen. The oxygen is going to take the electrons from the iron, but the oxygen needs 2 electrons. This top reaction, the reduction, needs 2 electrons. This reaction only gave us 1 electron, so we need to double it. We need to have 2 iron 2 pluses plus 2 Fe3 pluses, or 2 iron 2 pluses react to form 2 Fe3 pluses plus 2 electrons. We need the number of electrons to be equal on the 2 sides of the arrows in the 2 reactions. Now we've got equal number of electrons. We just add up our 2 reactions, add up the half reactions. Note, if you've done it right, the number of electrons will always cancel out. When you add these, we've got 2 electrons here, 2 electrons here. If your electrons aren't canceling out, you've done something wrong in step 6. So, is there anything else that cancels out? Well, I got H plus and H2O and Fe. I got Fe2 plus Fe3 plus H2O, but this is H2O2 and this is H2O, so nothing cancels out. So we added our half reactions. We got 2H plus H2O2 plus 2 Fe2 plus goes to 2 H2Os and 2 Fe3 pluses, and that is our balanced reaction for this one. All right. Ooh, yeah, it's a little bit more involved. Let's go through another example of it. Okay. This one looks nice. Let's take copper plus nitric acid goes to copper 2 plus NO plus H2O. Looks nice. First step, we need to write it in the ionic form. All right, and so we can write this as copper plus H plus NO3 minus goes to CO2 plus NO plus H2O. Note, the oxidation state of the hydrogen here, the H plus is plus 1. Hydrogen here is still plus 1. So this hydrogen is not part of the redox. It doesn't get reduced and it does not get oxidized. So you can not have to worry about it. The other thing is, too, you know that in acidic, we should write this down because it should have been obvious, but a lot of times it's not obvious. HNO3 is a strong acid. So by definition, this has to be in acidic solution if you've added a strong acid. But we'll make sure that we specify this as acidic solution. Since this is acidic solution, we know that in some of the steps we add H+. In one of the steps we add H2O, so we don't actually need at this point to include the H+ and the H2O in our half reactions. We can just say, oh, the copper is going to go to copper 2 plus, Cu goes to copper 2 plus, NO3 minus goes to NO. All right. And those are 2 half reactions. Now the next step, balance everything other than oxygen and hydrogen. Okay. Copper's balanced, nitrogen's balanced, done. Oxygen not balanced, but that's not this step. That's the next step. Step 4, balance oxygen with H2O and hydrogen with H+. All right, so my nitrate reaction here, NO3 minus goes to NO. Got 3 oxygens here, 1 over here. I need to add 2 waters. All right. But if I had added 2 waters, now my oxygens are balanced, but I added 4 hydrogens. So I have 4 hydrogens on the right side, none on the left side. I need to add 4 H pluses to balance out the extra hydrogens. So the end of step 4, I've got my 4 H pluses, I've got my 2 waters, and everything is balanced. The nitrogens are already balanced. 1, 2, 3 oxygens, 1, 2, 3, 1, 2, 3, 4 hydrogens, 1, 2, 3, 4, I'm good. Added water to balance the oxygens, which added hydrogens, added H plus to balance out those hydrogens. Note, in the copper half reaction, there are no oxygens or hydrogens, so I don't add anything for that one. It's okay. Now I have to balance the charges. Okay, the copper reaction, note I've got neutral copper on this side, 2 plus on this side. I need to add 2 electrons to neutralize 2 positive to get 0 charge. The same on the left side has to be the same as the right side in terms of charge. So far, so good. When I look at this reaction here, I see I've got 4 positive and 1 minus. Gives this side a net 3 positive. This side's neutral, so if this side is 3 positive, I need to add 3 negative. So I add 3 electrons to that reaction. All right, step 6 is we need to equalize the number of electrons. So note, at this point, it's a little busy, but at this point, I've got 2 electrons on the right side for my copper half reaction, 3 electrons on the left side for my nitrate half reaction. Good news, electrons on the product side up here, electrons on the reactant side down there, so that's good. But I need these to equalize each other out. How can I get 3 electrons to equal 2 electrons? Well, the only way is to multiply this top by 3 and multiply the bottom reaction by 2. So take the top reaction multiplied by 3 gives me 3 copper atoms go to 3 copper 2 plus ions plus 6 electrons. Multiply the bottom one by 2 means 6 electrons plus 8 positive hydrogens. 8 protons go to 2 NO3 minus plus 2 NO plus 4 H2Os now. Now 6 electrons can cancel 6 electrons, and I can add up my half reactions. Does anything cancel? Well, the electrons cancel, and nothing else cancels. So now my overall reaction is 8H plus 2NO3 minus plus 3Cu goes to 2NO plus 3Cu2 plus 4H2O. All right, and that's my balanced half reaction. And you're probably saying, okay, this sounds all right. I can, steps 2, 3, 4, those look fairly straightforward, but what about this whole first part about, not including the hydrogens because we include those later, and not including waters because we'll include those later, and just getting to this right here. How did I know to break up the HNO3 into H plus and NO3 minus? Well, because it's a strong acid. We know strong acids dissociate 100%, so you do have H plus and NO3 minus. And then you're worried, okay, that's great, but what if I forgot to do that? Well, check this out. Let's do this whole thing again, but seeing what would happen if you forgot to do that. First step. So now we'll start again, and you keep HNO3 together instead of breaking up into H plus and NO3 minus. So we've got our copper to copper 2 plus, HNO3 goes to NO plus H2O. All right. Balance the coppers, balance the nitrogens, they're good. All right, now we have to balance the oxygens and the hydrogens. Well, we see we have got 1 oxygen over here, plus this one means 2 oxygens. 3 over here means we had to add an extra water here. So plunk a 2 in front of the H2O. And then that has 1, 2, 3, 4 hydrogens. We've got 1 over here. So we need to add 3 hydrogens because 3 H plus this proton gives us the 4 H's pluses on this side. All right, so everything is balanced now except for the charges. So we note 2 electrons on this side gives 2 plus and 2 negatives. It gets us neutral. If we look at this side, we're at, okay, neutral on this side. We've got 3 H pluses, and that's neutral, so we need 3 minuses. Note, we're back to having 2 electrons on the product side, 3 electrons on the reactant side. Multiply the top one by 3, the bottom one by 2 to get the 6. And when we do all of that, we find out we get 6H plus 2 HNO3s plus 3 Cu goes to 2NO plus 3 Cu2 plus 4 H2O. How does that compare to our earlier product, our earlier reaction result? Well, that was 8H plus 2 NO3s goes to 3, 2, 3, and 4. Well, here's my 3, 2, 3, and 4. 4 waters, 3 Cu2 pluses, 2 NOs, 3 Cus. And then we realize, hey, isn't 8H plus 2 NO3s the same thing as 6 H pluses and 2 HNO3s? Just take 2 of these protons, put it on the NO3, that gives you 2 HNO3s. Yeah, so which means we get the same answer either way. Good news, it's not super critical for you to break them up into the half reactions. If there's H plus, well, you have to break them up into half reactions. It's not super critical. If you've got your extra atoms around, oftentimes it will balance just fine even with those extra atoms around, if those extra atoms are H plus and H2O, because you're going to be adding them in later. So don't worry too much about that. All right, and so this is great, and this is an acidic solution, but this only works for acidic solution. What if our solution is basic? Well, good news and bad news. Bad news, we have a slightly different set of rules for basic solutions. Good news is it's only slightly different, only makes things a little bit more complicated, and we will look at basic solutions in the next video.